Okay, so I saw something this morning that just completely stopped me in my tracks.
Oh, yeah. What was it?
$400.
For.
A single computer cable.
Ah. You must be looking at the Kramer datasheet. The CLS-AOCDP 66.
That's the one, and that is the mission for this deep dive. We are going to unpack why a 66-foot, so that's a 20-meter, DisplayPort cable has that kind of price tag.
Well, to be fair, calling it just a cable is maybe a bit of an understatement.
It really is. I mean, where does that cost even come from?
It really all comes down to the laws of physics.
Yeah.
You want to push 8K resolution at 60 hertz over that kind of distance.
Right, 20 meters.
You're fighting a losing battle against electrical resistance with normal copper wire.
Because the amount of data we're talking about is massive. The spec sheet says 32.4 gigabits per second. That's HBR3.
And that is exactly where copper hits a wall. People in the industry call it the digital cliff.
So the signal doesn't just get a little bit fuzzy or distorted, it just stops.
It just stops. It falls off a cliff. You get a black screen, or maybe some insane flickering if you're lucky. The signal just attenuates into nothing.
Which is why Kramer's solution is to swap the medium entirely. That's the AOC in the name, isn't it? Optical cable.
Exactly. They're not sending electricity for the video data anymore. They're sending light.
It's a hybrid architecture then.
A brilliant one. If you were to, slice this thing open, you'd find 4 tiny strands of multi-mode fiber optics.
And that's what's carrying the heavy video traffic.
Right. Light just doesn't suffer from that same resistance over distance that copper does.
But they kept some copper in there. I think I counted 8 copper wires running alongside the fiber.
They had to. Fiber is incredible for speed, but it can't carry power.
Oh, okay.
And it's total overkill for the low-speed handshake data. Your computer and monitor figuring out what resolution to use. The copper handles all those logistics.
And speaking of power, this is where the engineering gets really interesting to me. Usually with these long-distance extenders, you're stuck looking for a wall outlet to plug in a power brick.
Yeah. It's a whole extra point of failure.
But not here.
Nope. The optical chips they're using now are just incredibly efficient. This whole thing consumes less than half a watt per end.
So it just sips the power it needs directly from the DisplayPort connector on your graphics card or your monitor.
No extra boxes, no USB power injectors. It functions like a self-powered fiber optic system that you can plug in just like any cheap cable.
Except the cheap cable isn't built like this. The physical design is pretty startling. The whole thing is only 4.8 millimeters thick.
With a bend radius of 48 millimeters, which is surprisingly flexible.
That flexibility has to be for the people who are actually installing this, right? This isn't for a gamer's desk.
Oh, absolutely not. This is for professional integrators who are pulling wire through ceilings, through conduit, through walls.
Which would explain that LSHF rating on the jacket.
Low smoke and halogen-free. Yeah, that's a critical safety standard for any commercial or public building.
Because a normal PVC cable, if it catches fire,
it releases this thick, black, incredibly toxic smoke, chlorine gas. It's a disaster. This jacket is engineered specifically to prevent that, so it can meet strict building codes.
And it's tough, too. The spec sheet lists a pulling strength of 25 kilograms.
Which means you can actually haul on it to get it through a tight spot without snapping the delicate glass fibers inside. It's ruggedized precision.
So when you put it all together, what we're looking at isn't just a wire. It's a miniaturized, self-powered fiber optic network.
That's a great way to describe it. It's a complete system that solves the long-distance 8K problem without any of the usual headaches.
It really highlights a fascinating shift, I think. We've pushed video resolution and refresh rates so high that copper, a standard we've relied on since the telegraph, it just can't keep up.
The pipe now has to be just as technologically advanced as the data that's flowing through it.
It makes you wonder, as we push toward 8K, 16K, whatever comes next, are we reaching a point where the physical medium, the cable, becomes more technologically complex than the content it carries?
That is something to think about.
Something to mull over the next time you plug in a monitor. Thanks for exploring this one with us.
Always a pleasure.